Hello everyone. I hope you're all having a blessed day. Today, I'm excited to share with you a video that goes beyond entertainment. It's an educational journey, especially for those who are new to the field of construction. In this video, we will explore a comprehensive guide on how to construct a building, taking you through each step of the process. For those who are new to my channel, I encourage you to check out my previous videos covering a range of topics, from piles installation and slope protection to mat footing. The content is designed to provide valuable insights into various aspects of construction. Before we dive into today's video, I kindly ask you to show your support by hitting the like button, leaving your comments, and sharing this video with others who might find it beneficial. If you haven't already subscribed to my channel, please consider doing so and don't forget to ring the notification bell. This way, you'll stay informed about all the upcoming videos in this series. Thank you so much for being a part of this community, and I hope you enjoy watching and learning from today's content. Let's get started.
Scaffolding works. It is the erection and installation of vertical and horizontal frames which can be made of GI pipes or hard woods. These scaffolding is a temporary structures used to provide support for the installation of forms for columns, beams, and slab. It also used as the temporary access for workers.
Column stirrups, also known as column ties or column rings, refer to the installation of closed or open loops made of steel bars that are used to hold the main longitudinal reinforcing bars, also known as main bars or vertical bars, in a column. These stirrups provide structural integrity and strength to the column and are a critical element in reinforced concrete construction. Column splicing. Column splicing is a construction process that involves extending the main longitudinal reinforcement bars of a concrete column to reach its final height.
Column forms are an essential component of concrete construction, ensuring that the concrete is poured into the desired shape and structure. Proper installation of column forms is critical to the quality and structural integrity of the column. Ensuring that forms are level and plumb is a fundamental step in the construction process to achieve the desired result. Beam runners. The installation of beam runners is an important step in the construction process, particularly in formwork and concrete work. Beam runners are horizontal support structures made of materials like GI, galvanized iron, pipes or good lumber, and they serve as a foundation for the installation of beam bottom forms. Beam bottom forms. Once the beam runners are correctly installed and level, you can proceed with the installation of the beam bottom forms. These forms rest on the beam runners and serve as the mold for pouring concrete to create the structural beams.
Beam reinforcing bars. The installation of beam rebars involves setting and installing the reinforcing bars required for concrete beams in a construction project. Rebars are essential in reinforced concrete structures as they provide the tensile strength needed to resist bending and other structural loads.
Beam side forms. Once the necessary reinforcing bars have been correctly placed within the beam, the carpenters can proceed with the installation of the beam side forms, also known as shutter. Proper installation of beam side forms is essential for the creation of a structurally sound and desirable concrete beam. This ensures that the concrete is dry to the desired shape and size, which is critical for the overall integrity of the construction project. Beam side forms. Once the necessary reinforcing bars have been correctly placed within the beam, the carpenters can proceed with the installation of the beam side forms, also known as shutter. Proper installation of beam side forms is essential for the creation of a structurally sound and desirable concrete beam. This ensures that the concrete is dry to the desired shape and size, which is critical for the overall integrity of the construction project. Slab joists, also referred to as nailers, are horizontal support structures used in the construction of concrete slabs. They play a crucial role in providing temporary support for the slab forms, which are used to mold and shape the concrete during the pouring and curing process. Slab forms. Once the slab joists are correctly installed and level, you can proceed with the installation of the slab forms. These forms rest on the slab joists and serve as the mold for pouring concrete to create the concrete slab.
Slab main bars. This involves placing reinforcing bars within a concrete slab, typically positioned 20 mm above the slab forms. These main bars are essential for providing tensile strength and structural support to the slab. Slab extra bars, also known as distribution bars or top bars, are additional reinforcing bars that are installed above the main bars in a concrete slab. These extra bars are typically placed closer to the support or near the ends of the slab, usually at about 1/4 or 1/3 of the span from the support. The primary purpose of adding these extra bars is to provide additional tensile strength, help control cracking, and distribute loads more effectively within the slab. Electrical rough-in work is a crucial phase in the construction process, primarily in the field of electrical systems and wiring. It involves the installation of various components and infrastructure necessary to support electrical wiring and devices in a building. It sets the foundation for the final electrical connections and the installation of outlets, switches, fixtures, and appliances. Proper planning and execution of electrical rough-in work are essential to ensure that the electrical systems function as intended and comply with safety regulations. Fire protection rough-in work is an integral part of building construction, and it involves the installation of various components and infrastructure required to establish a fire protection system. One essential aspect of fire protection rough-in work is the installation of galvanized iron pipes, particularly when these pipes need to pass through structural elements like beams. Plumbing rough-in work involves the installation of various plumbing components and infrastructure during the initial stages of building construction. This work is essential for creating a functional and efficient plumbing system in a building. The installation of PVC stub-outs or sleeves embedded in concrete is a common aspect of plumbing rough-in work.
A structural inspection is a crucial step in the construction process to ensure that the structural elements of a building, particularly those involving reinforced concrete and steel, are constructed in accordance with the approved plans, specifications, and engineering standards. This inspection is typically carried out by a licensed structural engineer. It helps prevent potential issues that could compromise the structural integrity and safety of the building over time.
Electrical rough-in work inspection are a critical part of the construction process to ensure that all electrical components are installed correctly, safely, and in compliance with electrical codes and regulations. Inspector check the placement and secure attachment of electrical conduits, which protect and route electrical wiring. They verify that the conduits are appropriately sized for the wires they contain and that they are securely fastened to the structure. Inspector will see to it that electrical boxes are properly positioned and securely mounted. Also, they check for adequate support, proper alignment, and compliance with box spacing requirements.
So high, I'm hypnotized. What's up is down, what's left is right. Chasing stars and holding you. I can't see the end, but we'll see it through.
Plumbing roughing-in works inspection. To ensure that it complies with the safety and plumbing standards, inspector will review the installation of PVC stub-outs, sleeves, and other plumbing components to verify that they meet code requirements. In order to ensure that it complies with safety codes and regulations, inspector will review the installation, penetration sealing, and system integrity to verify that they meet the required standards.
Preparing for concrete works is a crucial step in ensuring that the concrete is properly mixed, placed, and tested to meet the required standards and specifications. Temperature testing is a key aspect of quality control in concrete construction. It helps to ensure that the concrete achieves the desired properties and strength. Slump flow test. The slump flow test is a standard test for assessing the workability and flowability of concrete, including self-consolidating concrete. Measure the diameter of the spread of the concrete flow, ensuring it falls within the specified range, not less than 40 cm and not more than 70 cm. This diameter is the slump flow. To assess the strength development of the concrete, samples are collected for compression testing. The collected samples are tested for compressive strength at specified ages, which are typically 7 days, 14 days, and 28 days. Grouting is indeed a construction process that involves pouring a mixture of cement and water, known as grout, into gaps, voids, or joints in existing concrete structures or between concrete and other materials. The primary purpose of grouting is to fill voids, provide structural support, improve the bond between new and existing concrete, and seal joints or cracks. Do not allow the grout to fully dry or cure before pouring the fresh concrete. Fresh concrete bonds best to grout that is still in a plastic, uncured state. The exact timing can vary depending on the type of grout used and environmental conditions, but typically, fresh concrete should be poured into the grout within a specific window of time, often referred to as the green stage of the grout. This monolithic approach minimizes the chances of cold joints or poor bonding between components. The interconnected nature of monolithic construction enhances the structural integrity of the entire building. The concrete in columns, beams, and slabs cures together, creating a more robust and unified structure. Pouring the concrete for beams and slabs immediately after columns helps create a strong bond and ensures continuity in the structural elements. Finishing. After the concrete is poured into the forms for beams and slabs, it's allowed to set and partially cure. The timing for this step depends on factors like environmental conditions and the concrete mix used. Generally, it's essential to wait until the concrete can withstand human weight without causing damage or leaving impressions. Before starting the finishing process, ensure that the concrete surface is clean and free from debris, excess water, or any other contaminants. Properly finishing the surface of concrete beams and slabs is essential for both functional and aesthetic reasons. Achieving a smooth, level, and uniform surface is critical for the performance and appearance of the finished structure. Additionally, it's important to ensure that finishing work complies with project specifications and industry standards to meet quality and durability requirements. After finishing, it's crucial to immediately initiate the curing process. Curing involves keeping the concrete surface moist to prevent rapid evaporation and ensure proper hydration, which contributes to the concrete's strength and durability.